Hi, I'm Tony. I go by Cryptomancer online. You can find me on Facebook as Cryptomancer Cosplay, on Twitter as The Cryptomancer, and also on Twitch and YouTube as just Cryptomancer. So I'm answering questions about how I was doing stuff on my Tyrael Marine cosplay with L-wire and LEDs. So I'm going to go over electrical stuff today. First, some tools. Most handy pair of wire strippers. The way these work, wire goes in this section based on what size the wire is. Clamp it, wiggle around a bit, and whoop, pop, off it comes. Utility knife. I end up using this for scraping off the phosphor coating on L-wire. I'll get to that in a bit. Pliers, also handy. Also have wire clippers here, and other diagonal cutters for cutting through more wire. Tape is also handy, so I have electrical tape. Comes in colors, but most of the time I just use the black. Clear tape. This is also handy for holding L-wire down to things, because you can't see this. Okay. Components of L-wire. So when you're going online and looking at L-wire to buy, they tell you that you need something called an inverter. So this is an inverter. This one has a switch for on-off, and this one has a flashing mode. The inverters on my Tyrael Marine cosplay don't actually have a switch, so the only way for me to turn those on and off is to unplug them from the battery. This one, comes with a connector for a 9-volt battery. The other inverter that I have is also 12 volts, so it ends up using a pack of AA's kind of like this, where it just plugs in and unplugs from the inverter. The other end of this inverter has plugs. This one has 2. My other inverters only have 1, but you can use splitters on this in order to attach multiple strands of L-wire. The limitation is that inverters are rated for a certain length of L-wire. So it doesn't matter how many times you split it up, but the total length is what this inverter can drive. And the L-wire itself. So I've got a couple of not quite used colors of L-wire here. The colors are mostly determined by the plastic coating, not so much the wire itself, which at the very core here, does that come through? Not really in focus, but you can kind of see that there's 2 little wires there, and then the core wire. The core wire is a solid piece of copper, and it's coated in phosphors. And so the way L-wire works is, when connected to the inverter, it treats the L-wire like a capacitor. So it's constantly charging it and discharging it, and so it's flipping the polarity very rapidly, and that causes the phosphors to glow. So that's what gets you L-wire to light up. Okay, and over on this piece, this is one that I've already attached the other end of a plug to. So this would plug in somewhere there, and if I turn this on, glows. And I don't know if the microphone will pick this up, but it also makes a high-pitch whine. All inverters make this high-pitch whine. Some people can hear it, some people can't. It varies person to person and inverter to inverter. There's pretty much no way of hiding this sound other than being in a loud environment, or really wrapping this thing up in padding or whatever, which isn't really worth it. I mean, because you can still hear it through whatever. Also, just regular wire. I use the 2 different colors for other things for distinguishing which is my hot side and ground side for electrical circuits. You can use those just as well on L-wire. For example, if I didn't need it to connect to the inverter here, and if I didn't need it to start glowing right here, you could extend these connectors just by adding however much length of wire. And back to one of these other ones where you can see the little wires. A lot of the times when you get L wire, the other end isn't stripped yet. Oftentimes in ordering, they'll have an option to say, "Oh, do you want us to strip and solder the connections on?" And if you're only doing like one or two, if you're comfortable with soldering and wire stripping and all that, then like me, I do it myself. In hindsight, however, having done 6 strands of this for the Tyrael outfit, maybe in the future I'd save myself the time and just pay for that. But since I was getting one big length and cutting it up into different sizes myself, I just took care of it myself. So the trick here with wire stripping on the L wire is because there are a couple of layers of plastic coat. So there's this outer one, which is usually the color that you bought, and then there's an inner plastic wrap that still holds together the copper and phosphor core and the 2 little wires that wrap around this thing. So 2 ways I've done this. One is to try to strip away just the outer layer and then try to get the inner layer. When that happens, sometimes you end up cutting through one of the tiny wires, and maybe that doesn't matter so much, but I try to get both wires to survive, to get better light out of the L wire. But I don't know how much it affects it to lose one wire connection. Another trick for stripping that I found, and I don't know if this is just luck or if I'm actually doing it right, is to try to strip it so as to get through both layers of the plastic sheath, because then when I pull it off, it ends up leaving the 2 wires intact. So let me see if I can do that with this end, which I haven't stripped yet. In this particular wire, I believe when I ordered it, they call it 2.2 millimeter. Slippery. Huzzah! Success! Oh, wait, nope. Did the other wire succeed? Nope, the other wire got cut. Err. So yeah, when that happens, try again. And I mean, if you're going to use like several feet of L wire, then losing an extra ½ inch here or there probably won't matter as much. So maybe if when you're ordering, if you're getting your length really specific, just get yourself an extra foot. It's probably worth the few bucks. Right, so this stuff is 2.2 millimeter, and I have on the Tyrael Marine outfit it's 2.6 millimeter. So that affects what size on the wire stripper you use to try to strip it. And this, I think, when I was going at 16 gauge, isn't going through all the layers quite right. So I'll do a little bit on the 18 just to get through the plastic coverings. Let's see if these come off cleanly now. again, just one wire. So yeah, it can be frustrating, but do this over and over and maybe more carefully. I don't know how I'm not doing it carefully, but yeah. So then the thing after that is to take the two little wires off to one side, take the utility knife in the other, and essentially scrape off the phosphor coating of the copper until you get down to bare copper wire, because that's what you're going to need to solder to. So much fun. Okay, now get the other side. Okay, and that would, give you enough to solder to. Let me just find where my connector. So a connector that hasn't been attached to L wire yet. Thankfully, for these, it doesn't matter which wire of the connector goes to which of the L wire. But because they're kind of close together, it's a little tricky to, get them in the right place to solder one, to get these in the right place to solder one together and then solder the next together. Another trick is to use heat shrink tubing. I have around here a bag of little sections that I've already done. And one thing to do is to slide those up wires before you solder them, and then after you solder them, then you slide those heat shrink tubing over your solder connections, and then heat shrink them. That way, these like two connectors here won't like short out, because if they were to short out, you'd have no light and you'd just fry your battery pack. I did that once almost. So yeah, I'm not going to show soldering because that's about as frustrating as stripping the wire, and I don't really have the space on my desk to do it. And I really wouldn't be able to explain the best ways to do it. There are probably plenty of other YouTube videos that'll show you how to solder if you're going to go this route. But yeah, so once the pieces are soldered together and heat shrinked, then it ends up looking like that. Okay, so moving on from L wire to LEDs, let me show the difference between a couple different versions. So this is a strip of surface-mounted LEDs. So it's a nice, strip. It's essentially already wired, and you can just peel the backing off and stick it to things. It also has markings on it for where the strip can be cut to make different sizes out of it. And every place that there we go. Yes, right there. So every place that it has this little scissor icon in the middle to show you that you can cut it here. It also has connectors on both sides, and they're labeled positive and negative, so that you can wire up, this section. I mean, the whole strip that I had had one connector attached to it, but if you're going to cut it and put it different places, it shows you where you have to do the soldering connection to put them. So that's another good use for wire. So besides the strips. Oh, the other thing with the strips is they already have the right resistors and parallel circuitry on it. So that all you have to do is connect it to power. This particular strip can be powered by either 9 volt or 12 volt power, so either 9 volt battery or again one of these AA packs. Okay, so other than the strip version of LEDs, there's also individual component LEDs, and this is maybe what you're more commonly thinking of when people say LEDs. So there is a positive side and a negative side, and these are determined by, in a lot of cases, the lengths of these legs, or also the size of the parts inside of the acrylic. So of course my camera isn't going to focus on really tiny things, and so for this one I know that this large component on the inside of the acrylic and the short leg are the negative side, and the other side is positive. And this matters when hooking it up to a battery, because if you hook it up backwards, it's just not going to light. And this is different than how the L-wire works, where it doesn't matter which way you connect it up to the inverter. And usually the inverter to its battery, they already take care of which side is positive and negative. The other thing with individual LEDs is you can only have so much on a single series circuit. If you're not up to speed on electricals and parallel series circuits, whatever, I'd recommend that's another topic to look up on YouTube. I'll be talking mostly about individual series circuits, because the combination of series circuits linked in parallel is how you get a lot of lights into a cosplay. But individually in a series circuit, you can only have, depending on your power source, maybe only 3 or 4 LEDs at a time. This is because each LED, in its spec sheet or whatever, may indicate that it takes a 3 volt forward voltage to illuminate. So if you have a 12 volt battery pack and a 3 volt LED, you're only really going to be able to power 4 LEDs. So in order to get 20 something LEDs in a suit, you're going to have a number of series LED sets, and each of them will just hook to the battery separately, and that makes them a parallel set. The other thing is, depending on how many LEDs you have in a group, like maybe one part of your prop or whatnot only needs 1 or 2 LEDs, and another part has the large grouping. If you only have 1 or 2 in a circuit, you need resistors to finish out the circuit, or else you can put too much power through an LED, and again let the magic smoke out by having it just explode on you. So what I have here, over bright. Why? Come on, camera. Maybe I'll try to light up. Okay, a little dark now. But so what I have here is a breadboard for testing circuits before I go and actually solder them up. It's not absolutely necessary for doing LED work, but it makes it handy for demo purposes like this. Let's see. Put this back where I have the circuit. Okay. So also what I have here. Okay. So I've got LEDs here. A number of connectors that little wire connectors that essentially connect the positive side from the breadboard up to certain rows up here, and other little wire connectors that go from the negative side of an LED over to the next LED's positive side, and so forth. And up at the top I've got a number of resistors, little tiny things, rated at different resistances of ohms. And I believe that the way I've got this set up is that when I connect it to power here to a 12-volt system, that one LED gets then 470 ohms of resistance before going to ground. Two LEDs gets like 270. Three LEDs, like the online calculator I use for these, yes, cheating, it says I only need an 82 ohm resistor, but the smallest size I found was 100. So having more resistance than you need is okay. Honestly, I can't tell the difference in how much dimming. If I really did too much resistance on a circuit, like a few thousand ohms of resistance or millions, I would see it dim, considerably. But between 82 and 100, it's not noticed. And my online calculator says that these LEDs, which are supposed to have a forward voltage of 3.5 volts, that a 12-volt system shouldn't illuminate a fourth LED, but it does. Nonetheless, I still have another 100 ohm resistor off of that, just because I understand it's not good to have LEDs without resistance in the circuit. So now let me try aiming camera in my workspace. I might turn the light back on. Okay for now. Bring out my power source. Plug that in. And then to switch on these guys, I have another little wire segment which I'm just going to plug in to certain parts on the breadboard. If I had more actual switch components, I'd wire those in instead, but I don't. Okay, now I can turn the light off again. So having all this plugged in, if I go here, I believe. Where's it here? This guy I have in the wrong spot. Ta-da! Okay, so this is powering one LED. That powers two LEDs. 3. And surprisingly 4. And honestly, I can't really tell the difference in brightness for any of these. They're just really bright, and I'm looking right at them. Okay, so now I'm disconnecting the power, because I've also had accidents with this sort of setup where if I leave the power plugged in and I'm wiring things around, I might accidentally short things out, and that just causes the battery pack to heat up until it wants to melt down. Okay, light, back up here. Okay, so after testing a circuit this way, with the right number of LEDs to a resistor, the next step would be to do soldering. Again, sorry I can't demonstrate this right here, but it also depends on what you're putting it in. A lot of the LEDs on my rifle prop, I had made, I took a piece of Sintra and drilled a hole in it for the LEDs. So essentially from the back side, I'd put in the LEDs, bend the legs over, making sure I had the right positives and negatives, and then I would solder them together in this piece of Sintra expanded PVC foam board. So I'd solder them in place there, put the resistor on it, so that way there's the positive side that comes into the LED and the negative side coming out of the resistor. And then I'd attach however much wire I needed to get over to where my battery pack was, because the rifle's long and like the barrel pieces are way up here and the battery pack is all the way down in the magazine. But yeah, so I did it into pieces of Sintra that would then go inside the prop in the right places. I know that a lot of the places that people use LEDs now are in gems in armor, and whether you're putting those into a resin cast or merely taking your wired LED and applying it with clear tape to the back of your cast gem, either way is going to light it up. Yeah, and then so then it's mostly just a matter of making sure you have the LED with enough with the right resistor attached to it, and then just wire its positive and negatives right back to the battery. Okay, let me put this guy away. Okay, so I think that's covered pretty much the basics of how to get components, wire them together, soldering's involved, what tools you need. If there's any more specific questions, leave me messages, replies, etc., and I'll try to get to them all. And thanks for watching.